policy development on plastic food packaging. So I think you're very so we have a very good participation. So I think it's a so it's a topic that interests you a lot. So I just will remind you the agenda first. So just remind you that this webinar is organized in the framework of an Erasmus Plus project that is called FitNESS. And so I will just briefly introduce the project first. And then you will have the first presentation from Joanne-Marc Simon from Zero-Waste Europe about the global policy initiative on plastics. Then we will continue with a focus on the new EU regulation on recycled plastic and industrial practices. So with Jean-Miro Julien from LNE. And then you will have a presentation from Olivier Vitrac from AgroParisTech INRAE about the safety issues for new and recycled packaging materials. And then Thomas Carbiovec from Institut Agro-Dijon will just finish and will present you one of the main tool of our project. It's the FitNESS platform. And then, of course, we will have some times with you to interact, some questions. So please don't hesitate to ask your question directly in the chat, and we will pick up your question at the end of the meeting. So very quickly about the FitNESS project. So FitNESS stands for Food Packaging Open Courseware for Higher Education and Staff of Companies. So it's a project that is financed by the Erasmus Plus program of the European Union. So we are gathering 10 partners from 7 different countries. So you have all the logos of the partners. So you have an idea of the different universities and the institutes that are present in our consortium. And so as you can see, it's a FitNESS 2 now. So that means that we had first the first project called FitNESS, which started in 2017 and for a period of 3 years. And during this first FitNESS, we already built a lot of things, like the FitNESS platform that we will present to you later. And so just more into detail about what we did in this first version of FitNESS. So basically, we were building on the fact that we have a need to reshape and accelerate the transition to sustainable production and boost innovation, so in the field of food packaging. And so we developed it was a development of the concept of mixed learning and training on food packaging issues. And then we arrived to the idea of creating a lot of content related to food packaging in order to contribute to the dissemination of the state of the art and also transferring the new approaches to professional students and teachers, so in Europe and also worldwide. So as you can see on the screen, so we have 3 pillars for the concept of our project. So it's first a validated content, so with a high quality, also an open source distribution format, so to make it as broad as possible and also as broad as possible. And we also have a search engine which is adapted to mixed education. So you will have some detail later. And so as you can see, so the materials covers so really every topic that are related to food packaging. So that could be the production, the characteristics, the safety, the recycled aspects, the risk assessment, etc. So it's so the ambition is really to have all the aspects related to food packaging into this FitNESS platform. And so, as I said, now we are in the second project, so the FitNESS 2. And so the objective is, of course, to build on the outcomes of the first project. So concerning the content, the ambition is to update and also to also broaden the content that was already prepared. And what we would like also it's to prepare more exercises, assignments, etc., evaluation tools, in order to have the possibility to give some academic and professional certifications. And of course, the third aspect that we would like to to work on. It's really to scale up and to disseminate FitNESS beyond our consortium, and so the broadest as possible. And so just one last thing, it's if you want to follow so what we are doing, so please follow us on LinkedIn and Twitter, because we will post regularly all the activities we are doing, and also some news related to food packaging. So we have a website, so FitNESSfoodpackaging.com. So you're welcome to follow also what we are doing, and just to let you know that we are organizing webinars every 6 months. So if you're interested, you can also follow this activity. And just also an advertisement of the next event that we're organizing. So it will be on 7 and 8 March in Porto, so in Portugal. So if you're interested, we are organizing a training session on the new recycling technologies and food contact material regulations. So it's a hybrid event, so you can participate either in presential or in online if you're interested. So if you want more information about the programs, the registration, etc., please go on our website and you will have all the necessary information. And so that's it for my part. And I will give the floor to Joanne-Marc Simon from the US WIOP for the first presentation on the global policy initiatives on plastics. Thank you.
Thank you, Gemma. I'll try to share my screen. Let's see. Where's that here? All right. You can see my screen, right?
Yeah.
Good. Right.
Yes. Perfect. Yeah.
Very good. So thanks, Gemma, and thanks to the FitNESS project for having me here. I will talk about the policies, European policies related to single-use plastic and packaging, and I'll try to focus a bit more on the plastic packaging aspects, because I understand is the interest of this project. First of all, Zero Waste Europe, for those of you who don't know, we are a civil society organization with like groups in 28 European countries. Where we do basically, we are trying to influence European policies here in Brussels, but we also mentor cities towards zero waste, and also collaborate with businesses in advancing zero waste practices. And yeah, we have together with our members, we're trying to make this a reality by working at the European, national, and local level. For the topic of today, the issue of packaging. Packaging has been legislated in Europe already since quite some decades. However, from the point of view of plastic, there was not any plastic-specific legislation until we started actually seeing the problems of plastic pollution. That's why back in the early, 2009, 2010, they started first some actions to stop single-use plastic bags. And that was when the European Union decided in 2014 to have the plastic bag directive, which is part of the packaging and packaging waste directive, that actually was the first attempt at European level to reduce consumption or use of single-use plastic bags, and that's a successful measure that has managed to reduce around 90% the use of single-use plastic bags. That was 2014. But as you know, the problem with plastic pollution continued to grow, and because of the public pressure back in 2016, 17, 18, there was big pressure for the European Union to legislate on the topic of single-use plastic. And the motivation for this was to basically stop the plastic pollution that we were seeing in the environment in Europe, but also around the world. So Europe decided to take the initiative to legislate on this and put on the table a series of measures to stop this, because clearly plastic pollution is not something that you can stop just by banning plastic or by it needs a kind of a tailor-made approach. This is why the approach of the European Commission was, let's analyze what are the most littered items, and based on the most littered items, we will intervene. So what does this directive deal with? It deals with the 10 more litter items out there. That's why I'm not going to go through all of these, but for what concerns the issue of packaging, there's food containers, there's cups, there's beverage containers, and many other items that you could find in the beaches, that you could find in the sea, you could find in the environment. So that's why we intervened in this. There was another regulation on the port facilities, actually trying to regulate the fishing nets also, because that's a big environmental problem, the abandoned fishing nets in the ocean. But that's not part of the single-use plastic directive, because fishing nets are not a single-use item. It's a different category. So that's covered, but not by this directive. So what did they do? Like, the approach was based on these most littered items. They tried to classify what are the items for which suitable and sustainable alternatives are exist and are available. And for those situations when alternatives exist and they are available, they would propose bans or restrictions to access the market. That's the example of cotton bud sticks, cutlery plates, straws, etc. These things would be banned. Then there's another category. These are what you see here on the right. The single-use plastic items for which there is an alternatives exist, but they are not readily available. Like it can be the case of wet wipes or balloons or tobacco filters, that for that there were measures to actually like internalize environmental costs, but not necessarily restrict them, because for the moment it was understood that these alternatives were not ready. And then there's the items for which there's alternatives that not yet exist, and for that basically there was some sort of internalization. Here on the left side, on the left column, you can see the different measures that were used to address all of this. There was from measures to reduce consumption, or bans, product requirements from an eco-design perspective, separate collection targets, labeling, marking targets, like for example, that sanitary towels, wet wipes, etc. When you sell them, they will need to be advertised that this is a plastic product. Don't flush it, for example, because that was a problem, like when flushing wet wipes, that was clogging the pipes, etc. So that's like with the cigarettes that you say, like this smoking kills. You would have similar things for like wet wipes and tobacco products, etc. EPR, extended producer responsibility, so that producers actually pay for the collection and treatment of some of these, and awareness raising. The directive is quite complex, but basically there's these bans. These bans started for cotton bud sticks, cutlery, plates, straws, deodorants, and sticks and balloons from 2021. And the idea was that we need to move to either reusable items or other alternatives. However, that proved a bit complicated, because since it is a directive, the implementation of all this legislation is a responsibility of the country, so the member states. So how this is implemented has been different. This is consumption reduction obligation for food containers and cups for beverages, cups and lids. And there needs to be a measurable quantitative reduction by 2026. However, here in blue, you can see what are examples of how this could be implemented. But what the legislation says is that the member states can adopt national consumption reduction targets, can include measures to push for reusable alternatives to single-use products, or marketing restrictions. And in blue, you can see some examples of like how you can implement this. That doesn't mean that this is happening. Some member states are using these ideas in blue, some others are not. And this is very important because that explains very much the proposal on the packaging and packaging waste regulation that I will talk about later, because that's kind of complementing this piece. Okay, so The extended producer responsibility is been applied differently to different products. So, for example, it's been divided by groups. So the producer responsibility for wet wipes and balloons are about data collection, whereas food beverage containers, wrappers, bags, cups, and tobacco products, the producers will need to cover the waste collection and the infrastructure to treat all this waste. So as different responsibilities, what is clear is that the producers will be asked to pay for different measures for different products. There's also obligations for the separate collection and implementation of DRS. DRS is deposit and refund, deposit return schemes. Basically, that you every time that you buy a product in a beverage, you would pay a deposit, and when you give back the beverage container, you would get the deposit back. So in here, there was an obligation. They established an obligation to separately collect 90% of beverage bottles up to 3 liters by 2029. There was not yet an obligation to implement deposit and return systems. The issue is that according to the evidence, the only way to get there is implementing deposit and refund systems. That's why in the packaging waste regulation that is being discussed, and I will explain later, that has been made mandatory. But for the moment, that's still under discussion. What is in the single-use plastic directive is only that you need to only get to 90% separate collection for PET bottles. That's only PET bottles. So, I mean, other containers such as food, packaging, etc., is not included in this 90% collection requirement. There's also design requirements, like, for example, that by 2024, all beverage containers will need to have tethered caps. Basically, that the cap, the lid of the bottle will need to be attached to the bottle itself, so that there's not the problem of like them being lost in the environment. And there's also the requirement to include at least 25% of recycled content in new PET bottles by 2025, which will increase to 30% for all beverage bottles by 2030. And this has been extended to other products in the proposal of the packaging and packaging waste regulation that, again, I will explain later. But for the moment, what is in the single-use plastic directive is the 25% for PET bottles. Then there's lots of obligations regarding labeling and awareness, as I said before, to inform that there is plastic in the product, that the product should not be flushed in the toilet, so they should be disposed correctly, misleading claims, compostability, etc. There's, of course, importantly, the ban on oxo-degradable plastics that are not accepted in the European Union anymore. And then, and to conclude, because I think I'm running out of my time, that's regarding the single-use plastic directive that was approved in 2020, and it's in application already. It's a directive. What is being discussed now is the packaging and packaging waste regulation. This is not final yet, so I'm going to present here what is been in the proposal of the European Commission. The negotiations will go on for another year, so it is expected that this regulation will be finalized by beginning of 2024, which is relatively quick. What is changing? With the packaging waste directive, it's being changed into a regulation. The difference between a directive and a regulation is that the directive, as I said before, is leaving to the member states the possibility to adapt the legislation to the national context and decide how they're going to implement this. This has been problematic because the different interpretation that the member states make of the EU law has caused that some member states actually do it very well and some others actually do it very badly. And what matters is that when looking at the last 20 years of packaging and packaging waste in Europe, it's clear that the tendency is that packaging waste is increasing, packaging use is increasing, recyclability it's not increasing. Actually, we have percentually in absolute terms this. We never had as much unrecyclable packaging in Europe as we have today, plastic packaging. And that is a problem. That's why the European Commission decided that we're going to make it a regulation. A regulation means that by the time that this is approved, which is 2024, this automatically becomes law in all member states, in order to avoid like this cherry picking from different member states who then decide not to implement this. So what does this proposal include? Many things, but for the first time ever, and because of what I explained, that the trend is that the packaging waste continues to increase, is to have a prevention target. That will be 5% by 2030, up to 15% reduction by 2040. Again, that's up for negotiation, but at least it's the first time we have a prevention target to have the obligation to start reducing packaging waste. Then, for the first time as well, there's it's included reuse and refill in the packaging legislation. So far in the packaging rules at the European level, there was no mention of reuse and refill. They were in the Waste Framework Directive that reuse is better than recycling, but the packaging directive didn't mention or didn't address reuse refillable packaging at all. There are proposed targets for takeaway food and cups, the HoReCa sector, wine, water, soft drinks, transport packaging, e-commerce, and transport packaging of large household appliances. Again, if you're interested, I can tell you what are the figures proposed, but these are just proposed, and for sure they're going to be amended and changed in the course of the negotiations with the European Parliament and the European and the Council. Then, and that's related to the single-use plastic directive I was mentioning before. The packaging and packaging waste regulation mandates obligation of deposit and refund systems for cans and plastic. So it's not leaving up to member states to decide how they want to meet the 90% collection target. Now it's going to be compulsory for cans and plastic beverage containers to use DRS. And for the moment, it's only cans and plastic containers, but we see, for example, that the carton beverage industry already is saying that they want to be included in the DRS, and they are in favor of like high collection targets such as 90%, which is interesting because from the only materials or the only industry that for the moment is left off the hook with this proposal is the glass industry, where they are being required to like meet recycle targets that are lower than the other materials. They're not obliged to follow to join a DRS system, and it looks like they will be allowed to actually like perform or have less performance requirements than other materials. Then there are also obligations for recycled content. For the moment, as you remember, in the Single-Use Plastic Directive, there was recycled content obligations for PET. In this case, we're already introducing recycled content for any kind of plastic. And there is the discussions whether we should have recycled content for other materials, such as aluminium, glass, etc. And then there's recycling targets that increase a bit the targets that were already in the Packaging and Packaging Waste Directive. There's a lot more things in this legislation, but if I would summarize it, what is interesting is that it's a regulation, not a directive, that it includes prevention and reuse, that it really increases the performance of recycling. So like when we talk about 90% separate collection with like essential requirements when it comes to the design of the packaging so that it's performing, etc., that is quite powerful. So if everything works well, we're going to have a European Union that moves to either high collection, high recycling content, or like a reusable packaging, which from a sustainability perspective, it's a nice scenario. This regulation doesn't take into account at all any health impacts of safety of the materials. That was left to the food contact material legislation that the Commission was supposed to tackle separately these days. But as maybe some of you know, this has been postponed to the next mandate. So we'll see maybe by 2025 or later, we're going to have legislation working on the safety of the packaging materials. For the moment, we stick to the old food contact material legislation, which is more than 20 years old, and it's really clearly ineffective. There's of course a possibility that in the negotiations for this regulation, we could, via the Parliament, include some safety requirements in the packaging. And to conclude, looking at the future, 2023 and beyond, as I said, this regulation of packaging will be finalized by early 2024, before the European Parliament elections that are for May 2024. And there's a food contact material legislation that is long overdue, but it will need to wait probably still like 3, 4, 5 years for this to come into effect, unless we find other ways to do this. And then there's a Global Plastic Treaty. The Global Plastic Treaty was agreed in UNEA Nairobi a year ago. It started with a process of 5 intergovernmental negotiations. The first one was in Uruguay in November. Second one is in Paris in May. There's going to be one in Nairobi in November, and then another one in Canada, if I'm not mistaken, before the signature. So this process should also be finalized 2024 or early 2025. For the moment, what is in the Global Plastic Treaty, it's been discussed mainly the scope and the procedure, so it's not very clear what is going to be in there. But having participated in the negotiations, what is interesting is that it's looking at plastic pollution with a wider lens. So it's not only packaging, it's also single-use plastic and probably beyond. It's including the health impacts of plastic, not only at the disposal stage, but also the extraction, manufacturing, use, and disposal. And we will see. I mean, it's too early to say, but and there's many considerations about this, but it's an opportunity, and we will see whether the European legislation will fit into the Global Plastic Treaty, or the Global Plastic Treaty, if it's finalized before, will end up influencing the European legislation. So that's too early to say, but as an introduction, I would leave it there. I hope I was not too long. Thank you very much.
Thank you very much for your presentation. So now the floor is to Jean-Mario from LNE.
Thank you, Gemma. I will share my presentation. Like it's very good. Can you see my share?
Yeah.
My screen, please.
Yeah.
Sorry. Yes, thank you. Well, good morning, everyone. I'm Jean-Mario Julien, and I am from National Metrology and Testing Laboratory, and I work especially on the characterization and the regulatory aspect of food contact material. Then today's presentation consists of a quick update on the evolution of the new regulation 2022 and 1616 relating to recycled plastic material intended to come into contact with foodstuff, and the impact of this regulation on industrial practices. So what about the evolution? And then the European Union recycling processes for the contact plastics are regulated by the regulation of 2022 and 1616. And then this new regulation repeals since September 15th last the regulation 282 in 2008. As a reminder, the old repealed regulation only concerns the mechanical recycling, more specifically of PET, as you can see on the top here. And the other types of recycling, such as the materials recycled on site and a closed loop system, the recycled material from a chemical depolymerization processes, and the recycled material used behind a functional barrier were not covered by this regulation, if we can say that. And the requirements for this old regulation were as follows. The raw materials had to be traceable and derived from materials initially intended for food contact, and the decontamination of undesirable substances is necessary and must be proven by a challenge test process. And the recycled material also had to comply with the rules of good manufacturing practices according to Regulation 2023 and 2006 by setting up a quality management system. And only permitted substances could be added to the recycled material, like for the Regulation 10 and 2011. And finally, the recycled materials had above all to comply with the Regulation 10 and 2011, which concerns plastic intended for contact with foodstuff. So this regulation had a number of limitations, as you can see on this slide. The first one is the recycled plastic had to be manufactured through an authorized process assisted by EFSA. And since the publication of the whole regulation, more than 230 processes were assisted by EFSA, and the European Commission authorized the recycling processes on the basis of a favorable opinion from EFSA. And the other thing is the old regulation excluded, for example, chemical depolymerization, production scraps of cuts, etc. And also the authorization procedure applied made many recycling processes illegal. And finally, it was shown that, if I can say that, the Regulation 10 and 2011 was not appropriate to manage accidental contamination, as is the case for recycled materials. And so the new regulation, all recycling processes and all plastic materials and articles are covered. The main objective of this regulation are to ensure that recycled plastic poses no danger to human health, and to identify technologies requiring individual authorization, like PET, like mechanical recycling of PET. And also to simplify the procedure authorization process, and especially set up a public register, which was announced in the old regulation but was never set up, etc. So under the new regulation, the safety demonstration of a recycling process must be carried out according to the 3 levels that you can see on your left. And that is to say, at the recycling technology level, at the recycling process level, and at the recycling installation level. For each level, you need to prove the conformity of the material. And you have an example here which clearly explains the difference between these 3 levels for a mechanical PET recycling process. From a technology, for example, from a mechanical PET recycling technology, you can have different mechanical, different process. And for each process, you can find them on a different country. And the final objectives also of this regulation is to prove the compliance of the recycled material according to the Article 3 of the Regulation 19 and 35 and 2004, which imposes the inertia principle, but also to prove the safety of the...
Studying.
There is someone who speak. Yes, it's
I'm
okay.
not like this initially. I became and
It's okay, Gemma.
Yeah. It's okay. You just need to turn your micro on again, Jean-Mario.
Okay, it's okay?
Yeah, thanks. Sorry.
Okay. Yes. I said that the final objectives of this regulation is to prove the compliance of the recycled material, and according to the Article 3 of the regulation 1935 and 2004, which possess the inertia principle, but also to prove the safety of the finished product from a microbiological point of view. And then in the regulation, you also have new concepts to consider depending on the type of recycling. Suitable technology as the mechanical recycling of a PET, and novel technology has the chemical recycling. Then, as you can see here on this table, no major change, and this regulation compared to the evaluation of the mechanical recycling process of PET, which is considered as a suitable technology with an individual authorization, as you can see on the column 7 of this table. In addition, closed-loop recycling system processes are also considered as suitable technologies. However, this system doesn't require an individual authorization request, but the recycling schemes or the recycling system applied shall be communicated to the European Commission before the start of exploitation of such a process. And then the specific requirements applicable to the suitable technology must meet the following points, as you can see here. You have control requirements over the collection and pre-processing of materials. You have also requirements for the decontamination of the materials collected according to the specification given and the annex to this new regulation. And you have also requirements on the post-processing and use of recycled materials, and particular compliance with the instructions provided by recycler. And finally, you have also requirements on the operation of the recycling system or recycling scheme within the framework of a closed-loop recycling system to be respected. And the assessment of the mechanical recycling processes of PET for the preparation of the EFSA dossier must be carried out according to the EFSA guidelines initially published in 2008, and which have been recently updated. And the risk assessment, that means the monitoring, supervision, verification, etc. of the processes are carried out by the authorities of the member states of the European Union. And then the introduction of this concept of novel technology mainly consists in building a set of robust data on the contamination and decontamination level of the materials collected, and especially allowing a certain number of processes to develop under public control. And then a process resulting from a novel technology can be placed on the market on a temporary basis without prior authorization before it becomes a suitable technology between 2 and 6 years after its assessment by EFSA. Example of recycling processes considered as novel technology are given down here. This is the case for the recycling of polyolefin like polypropylene and polyethylene, chemical processes also, and functional barrier layers and production scraps of cuts from production outside a closed loop system are considered as a novel technology. For a novel technology to become a suitable technology, the general provision, the general procedure to follow is as follow. The novel technology shall be notified to the European Commission and the national authority at least 6 months prior to the start of operation by the developer of a novel technology. And the developer operates and monitors the technology to collect data. It is an obligation. And the European Commission requests EFSA to assess the novel technology after at least 4 reports published on the developer's website. And EFSA assesses and publishes its opinion on the novel technology. Depending on the opinion of EFSA, the European Commission authorizes or not the novel technology as a suitable technology. And what are the general provisions to ensure the safety of materials collected for recycling? And first, the developer shall demonstrate that the novel technology can manufacture recycled plastic materials that comply with the Article 3 of the Regulation 1935 and 2004, which imposes the inertia principle and ensure their microbiological safety. And then the developer shall ensure transparency also toward the authorities, set up a permanent dialogue with the recyclers using the technology, give and exchange information in relation to the assessment of the novel technology on the contaminants and on the effectiveness of the decontamination. And the contaminants are level and the facilities or installation, and the food shall be monitored. As such, recyclers shall provide the developer with monitoring data, and the developer shall publish at least every 6 months a public contaminant report on its website. Finally, safeguard clauses can be applied at any time by the European Commission based on the opinion of EFSA or a member state authority. The Commission may decide to amend or revoke an authorization. What are the general provisions for official controls? And to ensure transparency and to facilitate the quality control and traceability, a public register should be established by the European Commission on its website to register technologies, recyclers, recycling processes, etc. And official controls will be carried out through audits, and in particular by examining the compliance monitoring summary sheet put in place by the operators. This summary sheet, you can find it in the annex of the new regulation. And then a declaration of compliance of the recycled plastic product shall be made by recyclers or operators according to the models given in the annex to this regulation. And finally, transitional provisions are given in this regulation for process authorization applications. And after the authorization of a recycling process by the European Commission, it is registered on an union register number, and the final product shall be appropriately labeled, and market operators shall provide written declaration of compliance and the supply chain. And well, to finish with my presentation, or to conclude, some questions are raised regarding the impact of this new regulation on industrial operators. And the first question is, what is the capacity, or what is the real capacity of the competent authorities at national level to respond to the various control of novel technologies within the period of 5 months following the notification of the developer of a novel technology to the Commission? And what is also the availability of skills, that means experts or the stakeholders, to evaluate a specific technologies? And do the specialized analysis laboratories and food contact material have really the capacity to support recyclers in relation to the high number of substances to be analyzed by implementing several analytical techniques? And the question may also arise about the availability of chemical standards. And also, there will surely, if I can say that, be additional cost to be expected for the analysis, for the implementation of a quality management system certified by a third party for the collection of the products, because it is also an obligation and the new regulation. And what is also the capacity of SME, that means small and medium-sized enterprise like recyclers, to meet all the requirements? And finally, what about the risk management and the event of a compliance problem with recycled materials already placed on the market on a temporary basis? So you can see here that there are a number of issues that are very difficult to address. Not only competent authorities need to have a new monitoring tools and the appropriate skills to specifically assess on new technologies, but also supply chain actors increasingly need to communicate to facilitate the transmission of information. And on the other hand, the analysis laboratories must set up analysis and transport modeling tool adapted to meet the needs of the various actors in order to help them comply with this new regulation. And then thank you for your attention. If you have a question, we can see that after the last presentation, I think. Thank you, Gemma.
Thank you very much, Jean-Mario. And so now the floor is for you, Olivier.
Good morning, everyone. You can hear me? Yeah. I share my screen. Do you see my screen?
Yes.
Is it okay?
Yes, it's okay. Yeah.
Okay. Good morning, and thank you for joining. That means we will move to a different subject. That means it's really related. The safety of new and recycled materials for food contact in relationship with the new obligation to use recycled materials. Please, the intent of the platform FitNESS and everything related is to provide you authoritative information and also quite up to date. My presentation today is associated to scientific results obtained within our group. That means we will focus on facts and new techniques to evaluate the risk for these new materials. And the intent is really simple. We want to provide that. We just want to provide to have on our market, that means a product which could be not safe. That means currently I'm based in the University of Paris-Saclay in the south of Paris. It's a new university. Please, if you have the opportunity, you can come and visit us. And something that I would like to emphasize and to make it really clear, that means we start to see a contradiction between the obligation of protecting the environment and another obligation to protect. It's compulsory to protect consumers. And we start to see contradiction. And last year, there was a call by our National Research Agency asking, please, we need to do research because there's something which is missing. We don't know how to manage the safety of these new materials. Please measure the walls. And I will try to provide some inches. Things that has been presented, I don't want to insist too much, but we are under an obligation of using recycling materials. That means so far, France, almost all packaging materials in plastic need to be recycled for full contact by January 1st, 2025. That means in just 2 years. That's something a little later for the EU, but please, the Waste Management Directive is under revision. We expect a major revision to be published in July. You have here the timeline. That means we expect something similar will come up. And the content of my presentation is simple to understand. When you produce a food, you have obligation of the safety of the food. Is why we have the techniques and methods. When you drink a milk, we can even recover the name of the cow which has been used to produce the milk. Even if you mix them, we have methods through prevention, through traceability, to have this information. Currently, for the safety of packaging, it's just a control on the finished product, plus environmental impact. Is it enough? If there is any problem with the packaging, the only information you have, it is written on it, milk. That will be really difficult to identify if something is going wrong with the materials that you recycle or that you reuse. You have to imagine, for people working with the food, it's difficult to understand where we put trash on one side and you have a product that you can eat on the other side. And we do that super fast. That means by 2025, 100% of plastic need to be recycled. For PET, 30% in Europe. It's really cellulosic, we reach 70%. And we have some molecules that are so spread in the recycling loop that we decided for France to ban them. That's the case of mineral oil. The only way to remove them is not to decontaminate cellulosic materials because they are not, is to ban all their use on the food packaging, but also on magazine, on leaflet, on everything which is printed. That's the only way to remove the contaminants. Currently, due to use of recycling materials, we will be obliged to reduce the shelf life. Some plastics won't, that means we will ban some eating in microwave oven for plastic packaging because they are recycled. Some of this packaging need to be used, they are safe only behind a functional boiler. We don't know how to manage repeated use. We don't know how to do border control. And it's also mandatory for some countries to identify endocrine disruptors when we don't know even the contaminants. That starts to be really complicated. We have really strong deadlines. And to be clear, that means the recycled materials need to be as safe as the virgin one. That's a law. There is nothing below. And I go quite fast on that. That means they need to be as safe. But how to identify the sourcing? Currently, they are so that means the tension are so strong on the recycling market. It's really difficult to identify the sourcing, whether they have been correctly decontaminated. It's difficult to relate a recycled content with a final use, direct contact, fatty food or not, to be used at high temperature, behind a functional boiler, for which duration. Okay, and are we sure that we can recycle these materials safely 5, 10 times, 20 times. All of that is really complicated, and the market is really global. And currently, it's really difficult to say that these flakes, whether they have been decontaminated, washed, or virgin, is really difficult. We just rely on documentation. That means declaration. Why not? But is it enough to prevent upcycling? Because the risk is coming not from downcycling. That means if you transform your water bottle into a shampoo bottle, why not? The problem is the opposite. If you have too much shampoo bottle in your water bottle, that starts to be a problem. And we have to manage all of that. And to show you that this can be a little complicated, that's an experiment done by a former postdoc in a group. We have two materials. You have one material which is formulated with polyaromatic molecule, another one which is a reception phase, but which does not contain the molecule. The molecule is in pink, you can see it. And you have water between, water, one other liquid, ethanol 10%, ethanol 30%. And the question is, can these molecules cross a liquid to reach the other phase? Can they travel? That means, is there any risk that polyaromatic molecules, because everyone claims that molecules are so hydrophobic, they cannot be transferred. There's no risk. We can wash anything we want, we can mix everything, nothing will happen. That's at least a claim. If we do the experiment with different liquids at different temperature also, we observe that in water, we can have a 2% transfer across 1 centimeter. If you take ethanol 10% instead, you reach almost 4%, and ethanol 30% is half. And for sure, that depends on time. But that means that there are some risks that need to be also to be managed, because we can have a transfer of chemicals without contact during the recycling loop. It's something that we demonstrated. You will have the presentation. We demonstrated this for single-use system. That means in multiple materials. At the time, we were capable to demonstrate there is a delay contamination between the over packaging and the packaging. That means that's something that exists. It's something which is also well known for paper and board. And I will show you some results. Because it has been observed that we have, that means since more than 10 years that we have a significant transfer of mineral oil from packaging to dry food. And initially, the content that has been found in food were really, really huge. And the problem is that you have the packaging and the food, and we have a lot of methods, either analytical, either with modeling, mathematical modeling, to predict the mass transfer in both directions. Now, what happens when we have streams, and in particular when we have, that means the presence in the same place of a material which is not too much contaminated, another one which is much more. Do we have a risk of mass transfer? Here I show you the result. It's quite old study. We were studying the migration of mineral oil from the over packaging to products similar to cookies for different categories of chemicals. You have the direction in days at 20 and 40 degrees Celsius, and there is a mass transfer almost of all species. Is why in France we have a regulation now that include, that means also that we manage the risk of contamination without contact, that even that we manage the risk for aqueous contact. This regulation is for cellulosic materials only, because it's not managed by the EU. But it's to say that we have a concern. And imagine when you recycle many times the materials, how to be sure that it is as safe as it was before? How to demonstrate that? Do you have any reference that justify that everything is manageable? That's the problem. And we are working on methods to be capable to identify unknown streams. In the past, we were working with analytical techniques. Okay, there are some limits because with analytical techniques, you cannot work so fast. And we try to work with techniques that are much faster and to be able to detect the origin of materials and whether a contamination occur. And the intent is for sure is to combine these techniques with migration modeling in the future. Then I show you some typical challenge. You have a two PET. On the left is a virgin PET, and on the right is a post-consumer PET with mixed origin. 5% is non-food. That's a chromatogram of GCMS, typically, is what you have. It's really difficult to identify with naked eyes that you have differences. There are. You can identify that we have one peak here associated to some mass spectrum. Is really difficult. And the question is, can we identify, or we have streams, and can we identify rapidly if they have been recycled, decontaminated with more food grade or not, to identify, that means a possible application. It's okay for food contact, but not for fatty food, not for oven. Is it okay for cosmetics, and so on, or need to be used behind a functional barrier? That means the intent is, do we have a method for that? The idea is simple. We have chromatograms where we encode them. In this case, we use a wavelet to transform, and we encode the signal for each ion that we measure. We will encode it, and we will be able to transform a GCMS chromatogram initially in a signal. I accelerate a little because I don't have too much time today. We can encode it, and not only in signal, because our intent is to convert the signal in letters, to compress the signal, to create a larger database, and to be able to compare samples together. And also to be able to measure the complexity of the signal and the amount of information, because we think that the information in the chromatogram, it's related to the chemical composition. Yeah, you have the kind of reconstruction if we compress the signal, and we convert the signal in letters. We convert, that means a variation, positive, negative, crossing zero, increasing or decreasing in letters. And with that, we can search for chemicals just by entering a regular expression. In this case, we are looking for oligomers, and we can identify rapidly where oligomers are. And even something we can do, we can compare chromatogram together. That means they are part of the signal that can be aligned. The part that has been aligned is a common information, is a common chemical information, is the same polymer. And the information that which does not match, or the gap, that's new chemicals, that's new compounds. And based on that, just by having two samples, we can compare them. And we will play with that. You have here some tested materials. We will test it on some PET streams. And on the right, we will do it on paper and board with something a little crazy. Initially, that looks really ambitious. That means if we have chemicals in the food, because food have food constituents, there are also chemicals. You have also the cardboard, also with some chemicals. And that means the packaging can contaminate the food, and the food can also contaminate the packaging. We have an exchange of information. That means if the packaging contaminates the food, we need to be able to detect a common information, a mutual information. And if the packaging includes several parts, we should be able to detect which part of the packaging has contaminated the food. Here, that's what we can do, just to show you, that means some of the performance that we can reach. You have different samples with a different origin, and here you have an unknown. And here, that's PET almost virgin, DNA, and the unknown is closer. And you have here post-consumer with a PET, that means that belong to a different category. Now we can measure the distance between the samples, and we can identify a radius where we could say this distance is acceptable or is not. For sure, I don't want to lie, because we generalize this survey with many samples that is taken from all around the world. The distance tend to increase with time with the recycling materials in the case of PET. It's really difficult to find now PET which is close to virgin one, even if they are decontaminated. We can detect that. I show you what we can do with cellulosic materials, recycled cellulosic materials. We were looking in particular initially, because it's non-targeted, that we were capable to detect these chemicals when they are black. That means that chemical that has to be identified, mineral alloy, polyaromatic, and some NIAS. We identify several. And the question is, can we recover a fingerprint and to detect which part of the packaging contaminated the food? And the intent is that when food and packaging are put in contact, they change the chemicals, they change information. And the overlapping part is the mutual information. That means if you see, in the case, food blue, which is cereal, which is close to the blue cardboard, that means that they have a change information. The other part of the sachet, that means it's far, they do not exchange information, they are really distant. With this kind of metric, we can identify which part of the packaging has contaminated the food and whether they did. And we start to generalize this approach, because it's not so specific, we cannot see which part, by developing chemical imaging. One of the techniques that we rely on now, it's Raman spectroscopy. Raman is really a weak signal. It's a vibrational signal of the molecules. It's a vibrational signature of the molecules. Here you have the Raman signal of water. It's orange if you use a green laser. And we have a typical signature, and we can identify chemicals. Please is something that is already on the rover Perseverance. Perseverance has a green laser to detect the chemical composition around. There are many things that has been published already, in particular to identify, that means layers in multi-layer material. We applied, in our case, to cellulosic materials, to paper and board. Here you have simple observation. You have in blue the signal of the cellulose, and in red we added a trans-stilbene. This molecule is really rigid with very symmetric vibrational mode. It's quite easy to detect. You see, if this molecule is present, there is no problem to detect it. And we did it even on a commercial sample. That was one of the very first measurements, and we collected its real sample on the market. And we identify along the cross-section of the packaging, that means the presence, if it is red, the presence of aromatic molecules. And the point is that these molecules are not uniformly distributed in recycled paper and board. Some fibers are more contaminated than others. That's not spread. That impact a lot our understanding. That means how the contamination can propagate through the recycling loop. And we try to understand that. We are now developing model materials that we are observing at different scale, in 3D, in 2D, to understand how the chemicals can spread through these materials and how they can be transferred just by single contact. That means it is known by the packaging industry as a set-off. That means the chemicals are just transferred because some materials has been put in contact. And initially, that you have a fluorescent dye, and Nile red is a fluorescent dye. And we try to identify whether we were capable to detect this set-off. First observation is that the way you spread aromatic molecules, that depend how aromatic molecules has been brought to the cellulosic materials. Here on the left, we brought them by dissolving them in ethanol, and you have a really good solvent. on the right, we brought them with a dichloromethane, which is not a wetting solvent or cellulose. And you have really a different pattern. That means here they are much more concentrated, much more localized. Here they're much more spread, almost everywhere. And we are studying now whether we can detect and explain the effect of a set-off by when one layer is put in contact with the other. And again, what we recover as an observation, that means the dye is in red and cellulose more green. You said something, that's false colors. That means it's not uniform at all, whatever the situation. We have not uniform covering. And if we work with real molecules, that means real molecules, that means not a dye. Here you have a PTFenyl, because that's a molecule we like a lot. And these molecules have a melting point which is really high. That means at room temperature is really crystalline. And you have here benzophenone, a photoinitiator. Here you have, and these images is without dye. We use Raman microscopy for that. And here you have a cross section, and here you see the fibers. And again, we see that there's only some fibers that are contaminated, not the others. And that means we have just a partial understanding how the contaminants can propagate, how they could be removed. And we are forcing the use of recycling materials. And in the case of paper and board, the only solution that we found to manage them is either not to use them for full contact or to ban some molecules. That means for us, the next steps, if that's working, I am, yes, is to create first a large database of fingerprints, signature of materials that we can consider safe. And to use this large database and repository to compare them with unknown samples. And if we identify some difference, to say, okay, we have to shift to other techniques to track specifically some compounds, to do some modeling. And also something good, since there are throughput techniques, with these methods, we can identify almost online. If you would use optic fiber, if you use a fast instrumentation, materials that could be not compliant. And if we detect a mass transfer, we can track back the cause of the mass transfer. And we can combine one day all of this information is new tools that we call safe by design. You can refer to this publication and to the open source code that's attached to it. And if I summarize rapidly, you have two possibilities. At the National Reference Laboratory in France, we are associated with, we have two methodology. The traditional methodology, which is one, that means you need to do an extraction. I mean, you need to extract the materials to have in a solvent your chemicals. Then either you use a target deformulation, you will compare your fingerprint with the fingerprint of each chemical. And you do that, and you will have a conservative exposure for one chemical, only one. Or you, step 3, you do a pair comparison using a material database, and you can work with thousands of chemicals, identify or not. And you can compare samples together to do a map in time, in space, in relationship with the technology. You can then follow a process to know whether you are still in safe margins. That means a lot of things to do, a lot of technology to develop. Is why we encourage, that means attenders, please continue your training and education. Even if you already are professional, graduated in the industry, we need to train all the time. Is why we developed the platform FitNESS. And with the platform FitNESS, you can have access to a lot of content. Up to date, we are improving. You can use any screen, to get access to it. Thank you a lot for your attention. And if you want to contact us, that means you can use my email. And we have 2 mirrors because we are developing the platform FitNESS. That means currently the master machine is mol12.agropytech.fr and the old machine is a fitness.agropytech.fr. Thank you a lot, and all of that could not have been possible without my research group. Thank you a lot.
Thanks a lot, Olivier. Very nice presentation. Thomas, so the floor is yours for the last presentation.
Yes, thanks. A good transition, and we'll go on with the FitNESS platform. Is the screen shared?
It's coming. Yeah, it's okay.
Okay, so it's also our pleasure to conclude on behalf of all colleagues included in the FitNESS project, as Gemma presented at first. We lost all the different partners on this slide. We are very happy to share with you also, as Olivier started, the FitNESS platform, which is dedicated to training about food packaging and training for all of us. I mean, for students, teachers, and also from industrial partners. So, but this FitNESS project, as Gemma presented to you, it's about food packaging, but that means we need to include also many other things. And as you saw, food packaging is a lot related to food science and technology. So you need chemistry, physics, microbiology, processing aspects, which are also very important. Packaging innovations, because this is also a field in which there are a lot of innovations, and especially now also, as we saw with the changes in the regulation, which is pushing for new materials. Social impact, environmental impact are also very important, and especially with the perspectives that are offered by the development of new technologies and new materials, which needs to be safe. So on this platform, you can find many different support, including lectures, of course, but many other things. You can use it for free. It's open access. You can use it for yourself, for lectures, for training, and you can use it on smartphone, on tablets, computer, and you will see different levels also. We define at first 2 levels, but we will change a little bit for 3 levels as novice, intermediate, and advanced, depending on what you would like to study, just starting with the basics on food packaging up to advanced modeling tools, as Olivier started to present to you. And as a few examples on this slide, you can see that you will have, as I said, not only lectures, but also webinars like for today. And as we started a couple of years ago on that project, it was just before the COVID crisis. And it helped us a lot also during the COVID crisis because we had a lot of online teaching at that time, and it was really useful tool in order to progress on that aspect. And so we included also a lot of different things. As you can say, you have some guidelines which can be specific to countries or more global, some case studies, some quizzes, some webinars that are included. So a lot of different things that you can find, like for example, you have some shelf life calculation related to food packaging. You have some migration calculation that can be also performed, taking into account the process, the storage. So you are most welcome. You have the QR code if you want to go on the website, and it's hosted on the server on University Paris-Saclay, and the contents are also updated from. So it will change also during the coming years. We are in progress also on that website, but you already have a lot of information, and the idea now will be to even better sort them to facilitate the use. So all new users are welcome, so feel free to go on this website, to navigate, to use the tools, to share the tools. Just credit authorship when you use it, and we'll be pleased also to welcome back your feedback when you will use it, in order to collectively improve ourselves on food packaging, and to be able to offer free tools like this one for teaching, for training ourselves, and to progress with a new direction that we will have on food packaging in the coming years, especially. So thank you for your attention.
Thank you very much, Thomas. So I think we have some questions in the chat. So I think I see that Olivier is answering to some of them. But I think there is a question from Adeline Marshall. I think it was related to the presentation from Jean-Mario Julien from LNE. Is it right? So if you want to raise your question, you can go on, or otherwise I can. So Jean-Mario, perhaps you've seen it in the chat. It's concerning the chemical depolymerization.
Yes, yes, I see.
Did you see
I
the question? Yeah.
Yes,
if you want
I
to
see
answer.
it. Yes, to explain that, I can say a chemical depolymerization can be complete in order to return to the starting monomer. In this case, the new material, if I can say that, will be treated according to the Regulation 10 and 2011 concerning plastic and tended to come into contact with foodstuff. And however, if the monomer obtained is not present on the European list, and Annex 1 of the Regulation 10 and 2011, this is the case, for example, for the depolymerization of PET to NBHET. The new material obtained from chemical depolymerization must be treated according to the new regulation on recycled materials. After that, if you want, all plastic recycling processes are considered in this new regulation, which was not the case before and the old regulation.
Thank you, Jean-Mario. Do we have other questions from the participants? If so, you can raise your hand if you want and ask your question directly. Yeah, please, Raphael.
Yes, I have a question regarding the proposal of the new regulation happening in the European Union. And it seems that there are many moving parts going on right now in many materials and many products. Is any platform or place where the discussion is centralized that is actually pertinent to that? Because there are many stakeholders involved in these regulations providing comments to the parliament right now. So I'm wondering if the FitNESS network could be the right place to the discussion be in place, or centralize a little of the discussion of all these moving parts for all these materials.
Yes, for my knowledge, we don't have this kind of platform, but you have the website of the European Commission. You can find some information about the needs of different actors and the supply chain. But it could be a good thing to have this kind of platform to have an open discussion on the different chemical technologies, for example, because this part we can have a lot of a problem with this part of the regulation, to treat this regulation. I don't know, I see Olivier raise his hand.
Yeah.
If you want to add something, Olivier.
Or one mark also.
Yes, one mark also.
Rapidly, that means we need to separate Raphael, that means risk assessment and risk management. That means when the EU Commission is, or that depend. For if it is related to food safety, European Commission. If it is related to environmental concern and so on, and environmental regulation, is the European Parliament. But anyway, if it is risk management, yes, they have to decide, sometimes against the opinion of scientists. They have to make their choice. Currently, if they touch a framework regulation, you have a public consultation. They receive the opinion. Everyone, industry, academics, we can leave some comments. They do more or less what they want. That's the way it is managed within the EU. But there is something else, which is risk assessment. Because usually if they manage the risk, it's because someone assessed that there was a risk. This part is completely free. That means you have associations, you have laboratories, you have lobbies, you have many things. And there's only diversity. And in Europe, because they are associated with us, you have the Food Packaging Forum. That forum where they put online facts they read, facts they read in scientific paper, but it's really completely open because we don't know what will be really the future and how to be sure that is maintained in safe margins. In fact, it's my opinion, but we start to have two groups. One, you have some groups that say we need to protect the planet. And you have others, such as my group, where we say, well, okay, we still need to protect the consumer. And how to construct a path between, it's difficult. But we are interacting. And even we have a debate because some member states start to diverge with the opinion of the EU. And for all the group of the materials, the EU is managing only a limited number of materials. But we were waiting for convergence for elastomers, we did not get it. For coatings, we did not get it. That means we did not succeed to merge several even European regulations into one. But for example, cellulosic materials is not managed by the EU. Printing ink is not adhesive, half complicated.
Juan Marc, if you want to.
Yeah, no, but very quickly on that. So, I mean, the packaging and packaging waste regulation, it doesn't deal with safety issues. And it's even, say this environmental, actually the legal basis of this regulation is internal market. It's not environment, even though the environmental aspects is very highly regarded. The safety part was supposed to be there with the food content material legislation that has been postponed. And I agree with Olivier, it would be ideal. That's what we're pushing to actually to bring together the safety, together with environmental impact, together with also economic and internal market. The Commission decided to go for this, and there's reasons in favor or against. The proposal of the Commission was impact assessed. So the impact assessment is available, but is impact assessed on the basis of the internal market, not from a safety perspective. And there's many conversations going on, like even inside the plastic, you have the ones dealing with PET, the polyolefins. So there's many conversations ongoing, but I would just encourage the FitNESS group to actually, like, any findings, any recommendations you have, feel free to put them out or pass them to us. We're involved in all these conversations, talking to the parliament. At the end, it's going to be a political compromise. That doesn't mean it's the best environmental or safest solution. Is going to be a political compromise. So the more evidence we can bring, the better. So feel free to share it with us.
If I may add something, that means we need to manage this really well, because once we accept something, that may become irreversible. That means we don't want to have something out of control. If we take the cellulosic materials, that's my opinion. Cellulosic materials initially was used a lot for food contact, recycled cellulosic materials, and at the end, after the crisis of mineral oil, they are not. That means most of the food industry tried to remove any recycled materials from the contact with food. They try to prevent it. Even the new law in France, the only way to remove the chemicals from the recycling loop is to ban the chemicals. Definitively. That means we don't know how to do that. And it's really, as soon as we authorize something that was not done before, it will be difficult to come back. Currently, even on the market, there are so many tensions that we cannot even identify, we cannot demonstrate for sure the claim in a document. It's difficult. Huh? That means we lack method. We are happy for some app, even from the US. There are some space for improvement.
So just on the, we are almost closing the webinar because we are still already running out of time. So I see that we have still, I think, 2 interventions. So Fatima, you wanted to add something on that aspect, or?
Yeah, thank you, Gemma. Just briefly to Raphael, a piece that I think it was not mentioned before is that Commission is working on a guideline for this regulation 1616, and I think is needed because, as Julian Giamario pointed out, there are many questions and many doubts from different stakeholders. And I think that this piece, this guideline will be very, very useful in clarifying several aspects of the regulation. Yeah, that's all.
Thanks, Fatima. Juan-Marc, you wanted to add something? Oh. No, it's okay. Thanks. So I think we have a last question from Rubatse. Do we... No, perhaps it's not so. Okay, seems no. So I think so. I would like to thank again. Yes. Okay. Yes, please.
Just have a concern. Thank you, Gemma. It's my first time to attend this beautiful webinar, and I was very interested. I'm Urwatse Bernard from Department of Food Science Technology, University of Rwanda. Just I consider that this food package materials project FitNESS is regulations is adding some new things into previous regulations e-commission. I was asking myself what was missing in European Commission regulations in 28. Thank you.
Thank you. I'm not sure I get your questions. So perhaps you can
repeat once again.
Yeah, or you can put it in the chat if you want.
Okay.
Thank you. I think just on the chat we had the last questions. It's how tight must the packaging be so that hardly any substances from the gas phase migrate from the secondary packaging into the packaging? So the question was raised because I wonder, because if it have a great barrier but conceals the bag tightly enough, something could migrate through the gas phases. So that was already I think answer from some.
I ensure it. I try to ensure it.
Yeah. Thanks.
And also a nice link for the debate from Zero Waste to Europe. I mean, so everything is welcome. Really, there's still some place for the debate. We are sure of that. And it's also why we think, that means to be positive with everyone, please continue your training and your education. We don't know exactly what will be the future. We try to provide the new tools and methods. That means, and new things are coming for sure. And we need to, also the practice will change. And even we think that with the compromise that will emerge, we will create even in some way some new economy, new opportunities. That means, please, that means if we want to resolve all of that, is through education. And also for Zero Waste Europe even. You can have opinion, but please, we need to train people in order they understand the concept. What does it mean? Migration, contamination. What does it mean? That means to manage risk. Because at the end, most of us, we try to forget what is really behind this concept. And if we understand it well, we can even contribute to the public debate. And we are still open society, just to get something constructive and positive for everyone.
Thank you, Olivier. So thanks again to all of you, so the speakers in particular, for your very interesting presentations. Also for all the attendees, so it was a great number. So I will, so the webinar was recorded, so it will be available on our YouTube channel, so you will receive the link. And also the presentation will be available on our website, so yeah, you can consult if you're interested. So thanks a lot again, and see you in the next